Con, sonar, new contact bearing 030, classified as Sierra 17. Confirming torpedo evasion maneuver.
Before a sonar operator ever steps inside a Virginia-class nuclear-powered attack submarine, they enter months of training that push them to the edge. Waiting for them is a $25 million system capable of spotting danger long before anyone on board notices. One wrong call can put over 150 sailors at risk. That pressure drives every hour of their 25-week course. This is the ANBQQ-10, and here's why the training is so brutal. Beneath the silent surface of the ocean, submarines from the United States Navy rely on a remarkable system called the ANBQQ-10. This sonar suite is the submarine's sensory powerhouse, blending both active and passive sonar modes to search, detect, classify, and track undersea threats. What makes the ANBQQ-10 special is how it was built. It uses a modular, open architecture design. Instead of a rigid, one-off system, the ANBQQ-10 evolves through software and hardware upgrades, allowing submarines to stay ahead of quieter and more elusive targets. The AN/BQQ-10 takes in data from multiple sensor arrays, including hull-mounted towed and bow-mounted spherical arrays, and then processes that information using powerful, off-the-shelf computing and advanced algorithms. It transforms raw acoustic noise into meaningful data, whether it's the faint hum of a diesel-electric hub in shallow water or an echo from a mine in a littoral zone. For a submarine crew, this means the ANBQQ-10 is more than a piece of equipment. It's the key to winning the undersea game of hide-and-seek. It can detect in complex environments where water layers, seabed contours, and ambient noise all conspire to hide sound, making it mission critical. In a world where stealth is everything, the ANBQQ-10 gives the edge. By installing this system across attack submarines and even ballistic missile subs, the Navy created a common sonar platform that can reduce maintenance complexity and improve training. The ANBQQ-10 gives submarines an edge in the high-stakes environment of undersea battles. And because of how important it is, it takes 25 weeks for the operators to learn how to use it. When you dive into the undersea world of submarine hunting and detection, you quickly see that this is not a simple game. For operators of the ANBQQ-10, every moment is filled with complex decisions and serious risk because the enemy is also hunting, hiding, and adapting. That's why it takes 25 weeks for the training process. In deep, open water, sonar performance is steadier but still challenging. Sound can travel long distances, but it also bends, refracts, and may bounce off seabeds or thermoclines. In contrast, when operations shift to littoral zones, these are shallow coastal waters with varying seafloor topography, heavy traffic, and shifting temperature or salinity layers, there are more challenges. Environments like these generate clusters, noise, unpredictable sound paths, and hiding places for submarines. And then we have the adversary. Today's submarines are quieter than ever, especially non-nuclear or diesel-electric boats that can submerge for long periods and slip into shadow zones that blunt sonar detection. An operator aboard a submarine using a sophisticated sonar suite has to interpret faint whispers amid all the natural and artificial sounds and separate friend from foe. They must discern assets that don't want to be found. Submariners need multiple sensors to make fast, tactical decisions, and most of this relies on the submarine sonar operator. A modern sonar system like the AN/BQQ-10 is linked to hull-mounted, towed, and perhaps flank or conformal arrays. Each sensor feeds data, but noise, environment, and platform motion all affect quality. An operator might detect something, but classification, threat evaluation, choice of mode between active and passive, and the decision of whether to hold or engage must happen in a matter of minutes. Any mistake can mean losing contact or risk becoming detected. Finally, the stakes are high. In anti-submarine warfare, failing to find a hostile submarine in time can allow it to strike a high-value target, disrupt sea lines of communication, or change the course of a conflict. At the same time, revealing one's own submarine's position by active sonar or other emissions might end mission stealth. The operator must constantly work under stress in a moving environment where the margin between success and failure is razor thin. In this setting, training for weeks is not optional, but essential. Before they can go underwater, they must simulate all the environments and tactics in a training period across 25 weeks to make sure they can handle high stakes during patrols and missions. When someone signs up to become a submarine sonar operator in the U.S. Navy, the first step isn't jumping around a submarine, but it begins with basic training on land. Recruits complete boot camps and then move to specialized training for submarine duty. For those who want to operate sonar systems, this means heading to the Submarine Training School at Groton, Connecticut. There, they attend the basic submarine school, which runs for about 9 weeks, where they learn the fundamentals of submarine systems, safety, and life under the sea. Once the basics are mastered, trainees transition to a more technical phase, which is the A School for sonar technicians, also located in Groton. This technical school lasts about 18 weeks, during which students study electricity, electronics, computer technology, and all the fundamentals of underwater surveillance. All important to understand and work with a system like ANBQQ-10. Technical school alone takes about 18 weeks before a sailor is formally rated as a sonar technician for submarines, but being rated is only the beginning. A system like the AN/BQQ-10, which has advanced sonar capabilities, multiple sensor arrays, and complex processing, demands more than generic sonar training. After the initial qualification, new sonar technicians would undergo system-specific qualification, learning how to operate, test, maintain, and interpret the AN/BQQ-10's arrays, from hull and towed to other acoustic sensors. But they can't learn it all on land. They have to go for on-the-job training aboard a submarine supervised by experienced sonar operators. Over 7 weeks, the trainees assist, observe, and gradually take on more responsibility as they gain proficiency. They never run the sonar on their first mission, but they support an experienced operator. It's a ride-along learning period before full operational control. From the basic sonar and submarine training to the system-specific qualification and apprenticeship, sonar technicians end up using 25 weeks to learn how the AN/BQQ-10 or any other complete sonar suite works. The complexity of the environment and equipment demands a lot of effort from technicians. Submariners must learn to manage passive and active sonar modes, interpret faint acoustic signals, maintain and troubleshoot electronics, and react quickly if a contact appears. Mistakes can jeopardize the submarine's stealth, safety, or mission success. Once aboard a submarine, after 25 weeks of training, the technician continues in real-world conditions. New sonar techs still don't operate the machine, but they log hours on watch, monitor sonar consoles, run diagnostics, and participate in drills. Maintenance of sonar systems, even simple checks or recalibrations, becomes routine. Submarines periodically perform sonar system maintenance both in port and at sea, which helps keep their hardware in top shape. As they gain experience, technicians can become better at it, and eventually, They're the ones operating the $25 million equipment to keep the submarine stealth while underwater. They can also pursue further qualifications like maintenance specialties, advanced acoustic analysis, or tactical sonar operations. Over a career, a sonar technician can alternate between sea duty and shore assignments, often returning to teach or maintain sonar systems. But you might be wondering why they have to take up to 25 weeks to learn how to use the submarine sonar. Training to run the sonar on a submarine is important to protect an entire vessel and crew under conditions where there is no second chance. A sonar suite like the ANBQ-Q10 is a highly expensive, advanced system that acts as the submarine's senses underwater. Because the stakes are so high, one mistake could mean missed threats, or worse, putting the sub and its crew in danger. So, sonar technicians must be extremely careful, exact, and ready. They have to go through the base training for 18 weeks first because they must build real-world familiarity using simulators or supervised operations. Even when on missions, they can only assist experienced operators at the start and then gradually take more responsibility as they prove capable. They must learn not only how to detect contacts, but also how to classify, track, and make rapid tactical decisions, often in high-pressure situations. Because sonar helps determine whether a submarine remains hidden or becomes exposed, the margin for error is razor thin. That's what the remaining 7 weeks are for. Combining the baseline training, system-specific qualification, and hands-on practice, it's easy to calculate it as 25 weeks. This is an investment in precision because the safety of the submarine and its entire crew depends on it. But training never ends for submarine sonar technicians, especially with the ANBQ-Q10 that's constantly upgraded. The ANBQ-Q-10 sonar suite has evolved, shifted, and been upgraded over many years to keep pace with changing underwater threats. Originally, the U.S. Navy recognized that its legacy sonar systems were falling behind quieter, more advanced submarines and more complex, littoral environments. To meet that challenge, they launched the Acoustic Rapid COTS Insertion Program, which helps them transform older systems into a more flexible, modular architecture. The key difference in this upgrade path was the adoption of commercial off-the-shelf computing and an open system architecture. Instead of a fixed hardware design that might become obsolete fast, the sonar could receive periodic software and hardware inserts to stay ahead. The upgrades worked in phases, and the submarine sonar operators had to keep up with these changes. Phase 1 targeted towed array improvements. Phase 2 added enhancements in both towed and hull arrays. Phase 3 replaced core processing for hull, spherical, and towed arrays. And Phase 4 took on high-frequency and under ice or mine operations for certain boats. Over time, the upgrades included new processing power, but also new sensor types, such as low-cost conformal arrays mounted on submarine sails and sides, enabling improved situational awareness in crowded coastal waters. The Navy also introduced more frequent update cycles rather than waiting many years between major overhauls. The Navy planned for annual software and every few years hardware insertion so that the sonar system could evolve incrementally rather than be replaced wholesale. These upgrades matter a lot because the undersea battlefield keeps changing, and the AN/BQQ-10 continues to keep up with real-world use. The AN/BQQ-10 gives a submarine powerful, real-world, underwater hearing and sensing capabilities that dramatically change what the boat can do. Because it uses modern computing and signal processing, the system can take data from multiple sonar sensors and combine them to produce a clearer, more complete acoustic picture than older sonar suites ever could. This means a submarine equipped with ANBQQ-10 can detect much quieter targets, even diesel-electric submarines that try to slip silently through the water. The improved processing gives enhanced passive detection, active search when needed, and better ability to track contacts in noisy or complex environments, such as busy littoral zones or deep water with shifting thermoclines. ANBQQ-10 also brings useful mission flexibility. For example, with advanced versions of the system, a submarine can map the seafloor, detect mines or underwater obstacles, and avoid hazards. These are important in areas where safe navigation is as important as stealth. For submarine crews, that translates to better ears underwater. They're more likely to hear whispers in the deep, the subtle sounds of an enemy hull, distant propeller, or underwater obstacle, even in cluttered waters. That means better chances to avoid danger, stay stealthy, or gain advantage. In real-world operations, surveillance, anti-submarine warfare, covert insertion or reconnaissance, and ANBQQ-10 give a decisive edge. But the only way for operators to achieve this real-world use is when they complete the 25-week training process. That way, they can make full use of this $25 million equipment without breaking it and protect their fellow submariners on board. Submarine sonar operators face extreme pressure underwater, but 25 weeks of intense training and hands-on apprenticeship prepare them to handle a $25 million system with precision. Their skill, focus, and discipline turn what could be chaos into control, keeping their entire crew safe whenever a faint ping appears on the screen. Could you handle 25 weeks of this? Share your thoughts in the comments. For more inside looks at life in the U.S. Navy, hit like, subscribe, and tap the bell. See you in the next video.